Good morning to all. Today we are going to discuss a case study by using mathematics concept. We all know how much important is our heartbeat. Is it possible to access the heartbeat variability accurately? If it's so, how we can do that? In this case study, we are going to find out a method which one is the best way to study the state of the heartbeat variability. In this case study, we are not going to do any mathematical calculations, whereas we are about to find which method in mathematics is useful to accessing the heartbeat variability. First, we should know what is heartbeat variability. It is nothing but the measure of beat to beat variations in heart rate is called the heartbeat variability. If your heart rate is 60 beats per minute, it does not mean the heart beats for every 1 second. It may have 0.9 seconds between the beats or 1.5 seconds between the beats, but at the end they have a total of 60 beats per second. Now, our case study is to find which method is the best analyze heartbeat variation for normal people is good or not. For this, we are going to use a new concept, that is design thinking concept. In design thinking concept, first we are going to use empathy part. Here we have to list out the various ways by which we can whether a person's heartbeat variability is good or not, that we are going to say. For that, we have some examples. Look at here. By looking at the face of the people, we can find out the heartbeat rate approximately. Also, by observing the behavior of the people, we can find out approximately the heartbeat variability. One more method. By checking the pulse of the people for every certain period and preparing the data with it, we can say the heart rate. Also, by using a machine predicts it whenever we need, we can say the heart rate. By all those activities, we can measure the heart rate approximately or accurately. Here we have to find out a major problem. For that, we are going to find out a solution. So these are the points which we are used to access heart rate variability. So now we are going to use define concept to find the solution. In define concept, we have to analyze the major problem. Here, if we can create a machine, we can find the heartbeat variability. Here, we are not going to create a machine physically. In mathematics, creating a machine is nothing but transforming signals in a body to a pictorial representation. Now we are going to ideate our problem. Our problem is now simplified to transforming body signals into a pictorial representation. In ideate part, we use various resources available to find the solution we need. Now, I am going to list out the various ways by which we can transform signals into pictorial representation. It includes Mohan transforms, Z transforms, Fourier transforms, Laplace transforms, and so on. Here, from the various ideas available, we have to find out one best idea for solving the problems. We go with Fourier transform. For this, we are going to prepare a prototype. Now, for prototype, to use Fourier transforms, we should know how to convert signal to picture. How? We have decided our best option is to go with Fourier transform. In order to use Fourier transform, we should have a clear idea about the Fourier transform and how it works. Basically, it works with time domain and frequency domain. In time domain, we access the signal with respect to time ratio. In frequency domain, we convert the signals for every certain period to number of times. With high and low peaks, the signals occur. Thus, it will be represented in tens format. How we can get the pictorial representation? By converting time domain to frequency domain, we can get the pictorial representation. Here, that is given in a graph. Usually, time domain measures standard deviation of beat to beat intervals, root mean square of the differences between heartbeats, NN50 or the number of normal to normal complexes that fall within 50 milliseconds, PNN50 or the percentage of the total number of beats that fall with 50 milliseconds. Also, in frequency domain measures ULF less than 0.0033 Hz and so on. Here it is given in the slide. So, if we know the above values, we can plot the graph for heart rate variability. Solution: if you are asked to find the heart rhythm of a healthy 40-year-old male driving and then hiking up the hill, what will be happen? Your solution using the Fourier transform will be given in a graph. Now it is given in the graph. You are seeing that this is the answer for that. The second question: if you are asked to find heart rhythm of a healthy 40-year-old male experiencing anxiety, the answer is given in a graph. Here you are seeing the answer. It is explained in the graph. Now another question: if you are asked to find heart rhythm of a healthy 50-year-old male during heart transplant recipient, the answer is given in the graph. If there is no heart rate in the graph, then the heart is not functioning. Now we have come to the conclusion. Thus, we can conclude that usage of Fourier transforms is the best way to find heart rate variability accurately. I hope you all have a satisfaction in measuring the heart rate accurately in my case study. Thank you so much.